So, yeah, last time we said superposition, which, yeah, we don't really understand, but that's okay.
If you do, please comment below.
Superposition is basically, yeah, where particles are in, hold many different states in suspension until they're collapsed when they're observed. We just, all we know is that we only observe the collapsed state, but when they're interacting on their own, they seem to, yeah, be in this, like, this state of superposition. Um, yeah, so so the question is, so we said that superposition allows qubits to hold many states at once. So yeah, you're kind of wondering like, wait, how? Because yeah, it's like the concepts are just pretty like vague or abstract, so it's not clear yet. It wasn't, at least it wasn't clear to me at first how it would be useful. Um, like in like actual computation, like if everything's indeterminate, then why would you use this to get like determinate answers?
Yeah.
But like there are like mathematical facts about the system that we know. Um, so basically, you can apply a certain, so yeah, to keep it high level because this is Christmas and where the best way I could explain is that there's a certain quantum gate that you can apply successively to keep all input values in superposition. It just has this is the gate here, like the way it's mathematically described. It's like a
Okay.
linear combination of zeros and ones. So this is like the basic unit of qubits, and then
Square root of 2. Why?
that's because that has to do with, because it's like a unit vector. That's
Oh,
just like reducing the size.
I see.
Um, but yeah, I don't think we'll be able to understand this completely in this video. But like, yeah, the key part to see is right here, where you notice like this is the basically the matrix U sub f is basically the matrix operation it applies. So that's like a quantum gate. Like that's a component of the circuit.
Okay.
So that's like one thing you can apply to the particle.
Mm-hmm.
And then when you apply that, then like f of 0, uh, then f of 0 is basically preserved in the next state. So this is like, so and f of 1 is also there. So that's the cool thing, is that you have like, so like each successive application holds both like potential input values like in superposition. So imagine like, when we compute like let's say f of x is like x plus 2 or something. Like in computers we have f of x, like if it's like 8, then we input this binary representation.
Right.
And then like we evaluate basically in each input value successively. Like we go through a for loop or something. In quantum computers, like you could actually, if you wanted to go with like 0 through 256, like all the integer values or something, like if you you could just apply this gate successively, and then also you have to represent the function somehow through linear algebra, but like plus 2 would be very easy to represent as a vector. So like if you could like hold all the potential input values in superposition. So like basically instantaneously you've computed f of x equals x plus 2 for values 0 through like 100, like 200 or something, or 0 through 1,000, like basically all at the same time. Like they're all parallelized, like all the input values are held in superposition.
Oh. So it's like you have like parallel, like you have a lot of computers working in parallel.
Yeah.
I see.
Yeah, and then you can evaluate them. You can perform an observation, and then you basically collapse the state to reach what turns out to be an approximate answer.
So this sounds like threads, like different threads in the
Yeah.
single computer.
Yeah, and the physical way to think about this is that it's basically a wave with like the particles emit waves that interfere in a certain way. Like imagine if like we had, I don't know, like light that was like super smart, and like the light like had these interference patterns when it interacted. or like sound waves have like an interference pattern, and it created this grid on like created this grid like on the table, and then like on the table we also had like a Sudoku puzzle that was gonna like tell us the solution to the Sudoku puzzle, and we like flipped on the light, and then like suddenly all the waves interfere, and then it puts like it shows these dots that represent like the numbers and it solves our Sudoku puzzle instantaneously. That'd be sort of what like quantum computers do.
Okay, I see.
Yeah. But yeah, of course it's way smarter than that, and they have this like specific mathematical deduction with like these states with these useful properties that they apply in a circuit.
Isn't there a news that Google's quantum computers discovered a fourth state of material?
Oh yeah, I'm not an expert in that, but that was called a time crystal.
Yeah. Is it related? Did they use quantum?
Yeah, I think they used like a quantum gate to create that. Yeah, to create that condition basically.
I see.
Like I think they used a quantum circuit.
Huh.
So yeah, it can be like some of the most exciting applications is like I think this is like of course like physicists knew this was like technically possible, but they're also the ones with like the biggest demand for it, because like they're gonna have like the most interesting applications in simulating different physical states and discovering different properties of particles.
I see.
So that was one instance of like a a real scientific publication that was driven by a quantum computer.
So can I understand it this way? Quantum computing can give you all the possibilities all at once, even the possibility that not yet exists in real life.
Yeah, it's pretty much, yeah. Basically, like it holds all of these different values in superposition.
Okay.
So yeah, it holds like we just know like that like particle spin is like very, very information rich, and it doesn't have to, like unlike other things, it doesn't have to just hold be in one state at a time, even though like that doesn't make logical sense really. But like basically like we just know there's some like higher dimensional structure that like produces like a particular state has an observable state that is lower dimensional.
Okay.
So sorry, actually I'm not sure if that's like technically mathematically accurate.
Okay, so
I didn't read this super carefully, but there's like a different observable vector, and that gives us like a different set of answers that just have some probability, but like the computation is like performed in this superposition, the state of superposition.
So do you think the quantum... So, okay, I want to give a disclaimer first. Don't listen to this video if you're preparing for a test.
Yeah.
Yeah, this is not
obvious.
Very serious. Yeah. So...
Yeah, I've just I don't know. Yeah, I've just like attended some lectures.
Yeah.
Just crashed some lectures to understand this, but I don't do research in this or anything.
So sounds like quantum is the key to all the possibilities in the universe.
Okay, so yeah, some people do say it. So when I started researching this, I found a book called Quantum Finance, which was not. I mean, it had some good material, but it wasn't like I didn't like I kind of disagreed with its like premise, which it seemed to argue that finance itself would be just totally, or we'd almost reached this point of singularity where like people think like because this is like the lowest level physical phenomenon, like they think like, and this is how like scientists and engineers think. They think it's going to literally explain everything.
It sounds like it contains all the possibilities.
Yeah, and there was also a science fiction series which was pretty good called
Which one?
I think it was called Devs. Yeah.
Huh.
Yeah.
Like DEVS?
Yeah, right.
Developers?
It was about this company that had a secret unit called Devs. Like that was like its code name. And then they turned out to be, like you find out in the first episode that they're creating a quantum computer that will basically predicts all of the future and can also infer to the all of history.
Is this the TV show or?
Yeah, it was a TV show.
Okay, if the producer of this TV show hears this, feel free to give us some commercial fees. Okay.
Yeah, well, but yeah, it was good, and it was about this. It was about this premise where like quantum computers are used to basically predict everything.
How do you know this TV show?
I watched it.
You watched it?
Yeah.
Oh, okay. So it's not very new.
Yeah, it's just one season. It's
I see.
Yeah, it's like a mini series. But yeah, it was like, this is something like science fiction writers have gotten very excited about. But like,
I can see that.
Yeah, I don't like. I think they're like just like with computers. Like, we thought like we were gonna have like, talking robots and stuff, but there are like fundamental computational limit. There are like fundamental limits to quantum computers. But there are
not.
There are.
There are.
But they're new. I'll get into that later. But there are new limits that I think will hold us back from just acquiring like all information in the universe.
Sounds like this can be the next breakthrough in technology, after internet.
It's definitely looking like that. Yeah, like this will be the next hardware technology.
Yeah, I think it will accelerate AI a lot.
Yeah. There are already a lot of thoughts about, because AI is just like, it's like differential equations on linear systems, and that's something quantum computers could do very well because their fundamental units are like vectors. And that's what neural networks use. They just have these big ass matrices to like represent all of their information. Yeah,
and if you can calculate all the possibilities in neural network at the same time, it'll save a lot of time.
Yeah, exactly.
And the computational capacity is huge.
Yeah, and of course there are already physicists or quack psychologists who like who want to say that this will explain all of the human brain, which I don't really think is true, but
is this
people are saying that because computers can't replicate the brain, there must be some quantum mechanics in how we think.
I see that in the future.
Yeah.
Oh, remember they also found out some new protein folding. Is that how they discovered the protein
probably
folding? Because it's so powerful, fast.
Yeah, I also like know very little about that field, but I've heard like material scientists are some of the groups that are have a ton of applications for quantum computers once the hardware is ready. So there will be a lot of push, and they'll keep developing because there's a lot of push for them in the scientific community.
I can see the next Elon Musk or the current Elon Musk will see this as the investment, the next investment.
You mean Sundar?
Oh yeah. Wait, I thought it's one of the Google founders who are interested in quantum.
Yeah, I think Sergey's like, I know Sergey's actually pretty knowledgeable of physics. He actually is in some of the lectures I watch.
Wait, he
attends the class.
Oh really?
I think he sponsors a lot of this. These efforts in the.
Cool.
Yeah, a lot of these research efforts in Google.
Very cool. Okay.
Yeah.